Hi, my name is Trey Austin. I attend North Carolina State University, and I did my research on a comparison of PBL heights by ceilometer and radiosonde methods in the Raleigh-Durham area. So going into a quick introduction of what I did my research on, the planetary boundary layer, which stands for PBL, is the lowest layer of the atmosphere where friction affects wind. And the height of this planetary boundary layer is important for studying air quality and weather processes. Um, The objectives of this research were to compare PBL heights taken from ceilometers against PBL heights taken from radiosondes. And quick definition of what a radiosonde is, it is a weather balloon which holds a radio transmitter that is carried aloft to sense weather conditions. And a ceilometer is a device that uses a beam to determine the height of cloud ceilings and bases and can also measure atmospheric aerosol concentrations. Um, Another main objective of this research is to compare PBL heights from the three different ceilometers that were placed around the Raleigh-Durham area. And I have these three sites on this map right here. This is the Durham site. This is the North Raleigh site. And then this is the Lake Wheeler site down here. And this is a picture of the ceilometer at the Lake Wheeler site, and it is manufactured by a company named Vaisala, which produces many environmental and meteorological instruments. Um, Now moving into kind of the more methods section, this picture right here shows a graph of the PBL height growth on like a typical day from a ceilometer. And there's a stable layer at the start of each day that starts a little lower. And then as it rises throughout the day, it forms into this convective layer. And right here is a side-by-side comparison of virtual potential temperature, which is this left graph right here, and then specific humidity, which is this right graph right here. And this dotted line on each graph shows where the PBL height is. And you can see that is when there's a sharp virtual potential temperature gradient inversion, lined up with a sharp decrease in specific humidity, that indicates that that is where the PBL height is. So now moving on to the last part of this presentation, which is the results. Um, this plot right here is overlaid with data from every 30 minutes from PBL height data from each of the three ceilometer sites. That way we can compare the trends in each of the three sites. And as you can see, North Raleigh and Duke and also Lake Wheeler, but Lake Wheeler wasn't really lined up correctly with each of the other sites because the site was down at specific times. But they all follow pretty much the same diurnal and seasonal trends. And then this scatter plot right here on the right shows a comparison of PBL heights from ceilometers versus radiosondes. And as you can see, the R squared value is very high, close to 1. It's at 0.9854. And that indicates that there's a very good correlation between the two. Now, the conclusions, we found that there is a very good correlation between the PBL heights derived from radiosondes versus ceilometers, which is what we just went over with this graph. And there was a seasonal trend in PBL heights with lower PBL heights in the winter. As you can see here, it goes down in the winter and then goes back up in the summer and then goes down again. And there's also a diurnal trend in PBL heights derived from ceilometers because PBL heights tend to grow throughout the day and start on the lower end. And then lastly, PBL heights across the three sites in the Raleigh-Durham area followed very similar seasonal and diurnal trends.